everyone. I hope you all are good and you all are practicing problems, learning concepts. Let us for now navigate through this question. Question में क्या कह रहा है? हमारे पास एक rod है, done है, and this rod is having mass of 5m and it is resting on a surface which is frictionless. Then there is a particle of mass m which is moving in this direction, and at certain time it will collide with the rod. And this collision is inelastic. Coefficient of restitution for this collision is given as 3 by 4. And just before collision, this particle had velocity equal to this much. One more information is given, that is if velocity of end B just after collision is 0. End B का जो velocity है collision के just बाद वो क्या है तुम्हारा 0 है. Then we have to calculate speed of ball just after the collision. So इस ball का collision इस ball की velocity just after collision कितनी होगी? So how we can calculate it? Again, this particle is striking the rod or colliding with the rod at this point, which is at a distance x from the end A, which is the upper end of the rod. Then x is also not given in the question. अब देखो इसको हम सॉल्व कैसे कर सकते हैं? सबसे पहले तो अगर हमने रॉड और पार्टिकल को सिस्टम माना, देन वट एवर फोर्स इज एक्टिंग ड्यूरिंग कोलिजन विल बिकम इंटरनल फोर्स एंड इन दैट केस वी कैन कंजर्व लीनियर मोमेंटम. तो चलो सबसे पहला इक्वेशन वहां से लिखते हैं. सो इनिशियल मोमेंटम ऑफ दिस सिस्टम इज व्हाट? रॉड तो इनिशियली रेस्ट में है, सो इनिशियल मोमेंटम इज एम वी नॉट because of the motion of ball only. And final momentum, finally let's say this rod is moving in this direction with vc. So it has linear velocity, it has gained linear velocity because of this linear impulse, or because of the force acting on this rod during collision, it has gained velocity vc in this direction. ठीक है? So basically vc is the velocity of center of mass of this rod. And let's say after collision this m mass has gained or is left with velocity v. So after collision ball की momentum कितनी है? mv, and rod has a momentum of how much? That is your m, m का value given है, that is your 5m basically. So 5m vc. Done है? This is how we can write linear momentum of the system and it will be conserved, इसलिए मैंने equate कर दिया. अब देखो m cancel होगा, so v naught is equal to how much? v plus 5 vc. This is first equation. We have to calculate v. Again, we don't know vc. So we need to do more. अब यहाँ पे देखो हमें क्वेश्चन में ये भी गिवन है कि b एंड की वेलोसिटी 0 है. ये कैसे पॉसिबल है? ये तभी पॉसिबल है इफ रॉड इज रोटेटिंग, क्योंकि आप ध्यान से देखो बिकॉज ऑफ a force acting on the rod during collision, its center of mass gained velocity vc in this direction, and from this one we can say that b will have velocity because of translation in this direction. And if b has 0 velocity, it means rod must be rotating also. Done? Because this force will have torque around the center of mass of the rod, and this torque will be in this direction. So if individually we just look at the rod only, then we can say F force has a torque around its center of mass, so it will rotate. And it is rotating in this direction, and then B point, because of rotation, will have velocity in this sense. Let's say angular velocity is omega of the rod, and then what will be the relation between Vc and omega? So Vc equal to omega L by 2. This is another thing. ठीक है, इसको आप मार्क करके लिख लो. दिस इज दिस थिंग. बट यहाँ से तो हमें एक और वेरिएबल मिल गया है ना, दैट इज ओमेगा. अब कैसे सॉल्व करें? So we can do one more thing, that is we also have information of coefficient of restitution 3 by 4, and also we can conserve angular momentum. तो देखो एंगुलर मोमेंटम अगर हमने कंजर्व करना है, क्यों कर सकते हैं? क्योंकि एक्सटर्नल टॉर्क इज नॉट एक्टिंग. ध्यान से देखो, आप रॉड पे फोर्स लगा F इन दिस डायरेक्शन, ठीक है, एंड दिस पार्टिकल पे भी फोर्स लगा होगा F इन दिस डायरेक्शन, right? So if we talk about system that is particle plus rod, then torque acting on the system around center of mass of rod मैं निकालती हूँ, suppose कर लो. So this one will be in this direction, and because of this force it will be in this direction. So equal and opposite, net torque 0. So angular momentum will stay conserved. Now what is the angular momentum of system around center of mass of rod initially? So I'm picking this point for the calculation of angular momentum. So initially देखो क्या है हमारे पास, this was moving with velocity v naught. So initial linear momentum is in this direction, and its moment around center of mass will be this much. So this distance is how much? L by 2 minus x into mv naught in which direction? In this direction will be the initial angular momentum. Now, what is the final angular momentum of the system? So if you have to write final, I mean finally, this is the rod, right? And this m mass, again, it is here, just here, and after collision, it has velocity. We have given it velocity v, right? In the same direction. So same thing we will be using here. So mv. Now what will be the momentum because of, I mean, what will be the angular momentum around center of mass of rod because of this mv? So that will be equal to mv L by 2 minus x in the same direction. And again, now this rod is also rotating. Done it? So center, I mean angular momentum of this rod around its center of mass will be ICM omega. ICM omega, right? Because अगर आप I mean this rod also has linear momentum equal to mv, sorry 5 mvc, right? Sorry vc, that we have taken as vc. So 5 mvc, but this 5 mvc will have zero moment around center of mass क्योंकि ये center of mass से ही pass कर रहा है. डन है? So rod का अगर आप angular momentum लिखते हो around center of mass of the rod, it will be giving you ICM omega. So this is here ICM omega and this will be equal to LF. आप इन दोनों को इक्वेट करो, ठीक है? सो नाउ लेट अस इक्वेट इट. आई मीन ICM ओमेगा प्लस MV L by 2 minus x has to be equal to, क्योंकि डायरेक्शन देखो इसका भी सेम यही डायरेक्शन होगा बिकॉज इट इज ऑल्सो ओमेगा इज इन दिस सेंस, राइट? सो ऑल आर आई मीन इन द सेम डायरेक्शन. इक्वल टू क्या करोगे आप? MV नॉट L by 2 minus x. Now ICM omega is equal to how much? L by 2 minus x. This is going to be equal to V naught minus V. Now V naught minus V अगर आप यहाँ से ध्यान से देखो, it can be written as 5VC. ठीक है? So यहाँ पे आप लिखो ICM omega. This will become 5VC. So यहाँ I'm writing 5M. L by 2 minus x into VC. Further, omega can be written as what? देखो यहाँ से omega को हम लिख सकते हैं 2VC by L. So let us write it. Omega is what? 2VC by L. And ICM will be equal to how much? Mass of the rod into length ka square divided by 12. So this is this into 5M L by 2 minus x VC. So VC will get cancelled and 5M will get cancelled and 2 से 6 will get cancelled. ठीक है? This is L. So 1 L will be over here. So this is L by 6, right? So L by 2 minus x is equal to L by 6. Done it? Now what will be x? This is L by 2 minus L by 6. So this will be equal to 12 by 6, that is L by 3. So x is your L by 3. So this will become how much? I mean L by 2 minus L by 3. So this will be basically L by 6. Okay? So this thing we have got. Now we need the value of v. What we can do? I mean अभी जो भी हमने इक्वेशन लिखा है, I mean here we have not so far got the value of VC. So we cannot put here the value of VC and get V. Also angular momentum का जो आपने इक्वेशन लिखा वहां से हमें मिला है क्या? We have got X. What else equation we can write? So we can write one more equation, coefficient of restitution का. और coefficient of restitution क्या होता है? That is basically a velocity of separation of the impact point divided by velocity of approach of the towards the impact point, right? So impact कहाँ पे हुआ है? देखो impact यहाँ हुआ है. And if you see velocity of approach towards the impact point, I mean this impact point is itself not moving. This rod is at rest. Done है? So velocity of approach आपको क्या दिख रहा है? V naught minus 0. What will be the velocity of separation? So I mean, after collision, this point has velocity. This point has a velocity how much? This point is on the rod. So rod, because of translation, it has velocity VC. And because of rotation, it will have velocity. I mean, it is rotating in this sense. So if you take rotation की वजह से velocity इसी direction में होगा. So this is omega L by 6, right? So this is this. So impact point का velocity after collision is Vc plus omega L by C, and this has a velocity of V. So with what velocity this impact point is getting separated from this particle mass, from this ball. ठीक है? So आप बोलोगे Vc plus omega L by 6 minus of V, and this is equal to how much? this is equal to 1 by, I mean, this is 3 by 4. Done it? So we need to solve this one. Now let us skip the patience and let us put the values. So VC plus ओमेगा को मैं क्या लिख सकती हूँ? देखो ओमेगा को लिख सकती हूँ 2 VC by L. So I will be putting here 2 VC by L, and this is into L by 6. Okay, and this is minus V equal to 3 by 4 V naught. Okay, and here if you do this, L will get cancelled. This is 2 3 VC by 3, so this will become 4 VC by 3. So 4 VC by 3 minus V. V को आप क्या लिख सकते हो? देखो V को आप लिख सकते हो V naught minus 5 VC. ठीक है, so let it keep it here. Let us first calculate VC, then we can calculate V. So this equal to how much? This is 3 by 4, right? 3 by 4 V naught. So this is 3 by 4 V naught. Now let us further solve it. So 4 VC by 3 plus 5 VC minus V naught. This will go this side. 3 by 4 V naught plus V naught. ठीक है? So this will become 19 VC by 3 is equal to 7 V naught by 4. ठीक है? अब देख लो यहाँ से वी नॉट का वैल्यू आप पुट कर दो. ठीक है, सो 7 by 4 इंटू 76. सो 19 से ये 4 टाइम्स में कैंसिल होगा, 4 4 कट हो गया. सो VC इज इक्वल टू 7 into 3, 21 मीटर पर सेकेंड. सो इफ यू नो VC यू कैन इजिली कैलकुलेट V. ये कितना होने वाला है? V नॉट माइनस 5 VC इक्वल टू V. ठीक है, सो V नॉट इज 76 माइनस 21 इंटू 5, नेगेटिव आएगा, यानी कि हमने जो डायरेक्शन लिया है वो गलत लिया है. ठीक है, सो दिस विल बिकम 76 माइनस 105 इक्वल टू V. सो V इक्वल टू 29 माइनस 29 मीटर पर सेकेंड. माइनस साइन इंडिकेट्स दैट मैंने कोलिजन के बाद इनकी वेलोसिटी आई हैव टेकन in this direction to be V. So it will be in this direction V. Okay, so that is 29 meter per second towards left. आई होप दिस क्वेश्चन इज क्लियर. एंड एक्चुअली इस क्वेश्चन को करने के बाद आपके बहुत सारे पॉइंट्स क्लियर होंगे. सो दिस वाज अ वेरी गुड क्वेश्चन आई वुड से, एंड आई होप यू हैव गॉट इट. आई मीन देखो, कोएफिशिएंट ऑफ रेस्टिट्यूशन लिखने में हमें बहुत केयरफुल होना था. सो इसको मैं एक बार और एक्सप्लेन कर दूं. यहाँ पे पॉइंट ऑफ इम्पैक्ट था, राइट? सो दिस वाज द पॉइंट ऑफ इम्पैक्ट, एंड व्हाट इज द रिलेटिव वेलोसिटी ऑफ अप्रोच between these 2 points initially. So this is at rest, so velocity of approach is V naught minus 0, and after collision you can see this point has a velocity in this direction equal to VC plus omega L by 6, and this I have taken velocity equal to V in this direction. So which is getting separated? Rod will get separated after collision. So VC plus omega L by 6 minus V is the velocity of approach, and approach by velocity of separation, and separation by approach is equal to coefficient of restitution. So I hope it is clear. यहाँ पे हम लोग काइनेटिक एनर्जी कंजर्वेशन नहीं यूज कर सकते थे क्योंकि कोलिजन इनइलास्टिक था. ठीक है, so I hope it is clear, but if you have any doubt anywhere you can always let me know in the comment section. Thank you, take care of yourself, bye bye.